We attempt to improve word vector representations for synthetic languages, focusing on German and Turkish in this project. We try to address the problems of word rarity and complexity in word representations. Agglutinative languages like Turkish have grammatical functional morphemes as affixes and try to build complex words. As if we were their children, for example, is a single word in Turkish, çocuklarıymışızcasına, while in Chinese, for example, 就像我们是他们的孩子一样 would be different words. In German, for example,
Rechtsschutzversicherungsgesellschaften
would be a single word that means group of insurance companies providing legal protection, in which case we see that it combines content morphemes by concatenating nouns. The nature of these synthetic languages cause single words to have multiple aspects of meaning, and make it very rare for the same word to occur multiple times. Stemming effectively destroys these agglutinative languages. The resulting word vectors become meaningless, so we need a model that can capture morpheme units really well.
As a baseline to arrive at such a model, we developed glove models for German and Turkish by training on monolingual transcriptions of TED Talks and news articles. To uncover syntactic structure at the word level, we experiment with splitting words into their constituent morphemes. We use morpheme parsers and stemmers available from other researchers. For Turkish, though, we built a very simple custom deterministic stemmer, which was not too hard since the language is extremely regular. We were able to obtain some useful morpheme combination visualizations from this approach, and this figure gives a comparison of TSNE embeddings before and after splitting morphemes. The German word Organisationsstruktur and Firmenstruktur, meaning organizational structure and company structure, are regular words that are still too infrequent to give good co-occurrence statistics in GloVe. We can see that by decoupling these words into underlying morphemes, we seem to unlock some desirable structure. After splitting the morphemes, Firma and Unternehmen, which are both synonyms for company in German, are closer together than Organisation, and Organisation is closer to its meaning as structure.
Another model that we developed is a neuromodel. Here, we train word embeddings for each language via an LSTM that operates on characters in each language to form word embeddings, and then have an LSTM that operates on the word embeddings of the source language to form sentence representations, and then a sentence decoder that seeks to output a vector close to the word embedding of the next target language word at each time step. Instead of building dependence between word representations by modeling a word as the composition of its morphological units, we assume that orthographic similarity implies functional similarity and represent a word by composing representations of its characters. So currently we're using a baseline sentiment analysis task to evaluate a morphologically split GloVe and neural embeddings as features. The results between the two are comparable so far, but we plan to further refine the neural model and add more evaluation data. A close-up analysis of Turkish embedding shows that the representations can't understand vowel harmony, and there are different spaces that contain vowel patterns. All A and based suffixes are in different spaces, even if they have the exact same function.